Hi everyone, my name is Mario Vuksan and I'm one of the founders of Reversing Labs. Here's Tomislav Pericin, who is another founder of Reversing Labs and another team member of ours, Mario Svajac. And we are a company that pretty much works on reversing tools and produces both open source, free and closed source components. And today we are here to talk about a new open source project that is going to be very accessible and very useful to really wide audience of both researchers and companies, and it's called TitanMist. Our goal for this tool for over the next several years is really to be part of your daily life, and as we want to call it, something that's going to bring the peace, to or some sort of calm, to your reversing activities. Anyhow, so let me just give you a sense of what we're going to talk about in what order. For one, we definitely want to explain why we wanted to put together TitanMist, what sort of the problems it's trying to solve, and really its effect on the what we call human aspect of the security industry. All the issues and problems and things we are dealing, and how hopefully TitanMist will be able to make some difference. After that, we're going to really go deeper into the dynamic analysis, unpacking file formats, and give you a thorough overview of TitanMist, what sort of infrastructure it requires, what it takes to modify it, its code base, and obviously collaborative parts that this project is all about. And then finally we're going to look at our knowledge base of file formats that are intrinsic part of this project. So anyhow, let me just bore you for a few minutes about the sort of high-level motivations behind us. And it really sort of boils down to the individual that's operating in various facets of security today, doing malware analysis, reverse engineering, and or penetration testing, where obviously skills are paramount element. Nothing you can really learn in a school, be educated. It's really all the stuff that we ourselves had to pick up, and you're never really sure if you really know everything that it takes to deal with the problems at hand. And then obviously at the same time, you want to have a toolbox, with you, a toolbox of things that can help you complete the job. And when it comes to toolboxes or tools, they generally come up in two very disparate categories. They're either very expensive commercial products, geared towards larger organizations, not really targeted towards smaller researchers, independent analysts, or others, or are they're free or open sourced tools that have been produced for a conference or two, maybe they lived for a year and then abandoned. I mean, generally poorly supported. Granted, there are some really notable exceptions, OliDebug and Metasploit being, definitely examples that, we ourselves, want to live up to and, be with TitanMist, for a year and try to have, as many people collaborating for obviously the benefit of everyone else. And when we're really talking about working together, just want to sort of take back and say that industry hasn't really been collaborating on research very much in the past, but with the growing problems, growing numbers of all types, there's more and more researchers, investigators, and especially security companies exchanging data, collaborating, forming various closed or open lists, for shipping data. So, but as that, the number of data sets is growing, so are the sample collections that come in with whatever analysis you have made. And with expanding collections come the problems, so, how do we compare the stuff that I got? So if I worked on Stuxnet and another person worked on that, how do we compare the samples, our notes? What are these samples, where they came from, how do you get a baseline with them? So obviously for anti-malware stuff, it really starts with naming and behavior conventions, old problem, the really bad stuff, which gets only more complicated when you start looking at underlying, packing and protection formats. And then finally, people, when they compare things, start looking at, where did you get this sample? Did you try to unpack it? Is this an unpacking variant? Is it replicated? Did it have run? And then finally, if you send me a report with your collection, really, what did you use to identify the samples with? If you use PID, what set of signatures did you use along with it? There's nothing really standardized. There's really no revision version that we could use just to compare the notes and be able to compare what we have and what we don't have. So hence it becomes very difficult to really compare the submissions or collaborative data from lots of different resources, because there is no standard, golden standard on what these things are. And obviously unpacking is another thing. If you try to unpack it with one of the 800 free scripts or any of the AV tools, it's very difficult to really compare what version or what has happened depending on the protection methods used by a packer or protector. So to sort of cut the real story shorter, we envision TitanMist to be a unified unpacking solution. Because we believe people definitely need better tools. They need tools that are integrated. We really want to put together the PID, lots of all the scripts, all sorts of other little tools into one thing that you can download, you can rely on, have a version on it, and a tool that will identify sort of disparate functionalities of format identification, analysis, and then obviously unpacking. And this has to be alternative to commercial solutions, because there's really no guarantee that everybody can have the same commercial solution, be it an AV product or being one of the commercial sandboxes. So it's very important that we have an open, free, and sort of let's say vendor-independent solution. And as such, for example, we are collaborating with the IEEE Malware Working Group, where that organization, for the benefit of the vendor collaboration, will add one more module to TitanMist. It's the format identification library that was developed by Peter Ferry of Microsoft. They're still clearing the licensing issues to release that into public. And we have already asked if we could potentially include this part for the general public, but we do expect that at least to be integrated with TitanMist in the short term, and hopefully given to everybody, not just vendors who participate in an IEEE work group. Anyhow, so just a second. Yeah. So the bottom line of this thing is that we have pretty much two sets of goals. One are technological goals, another one are community goals. So we want faster analysis for different use cases, be it malware, cracked software, vulnerable applications. Whether you're interested in removal of obfuscation or building of better heuristic systems, and then obviously we want this thing to be highly accessible. So the full install, not just source code that you have to compile and and deal with, but something that's easily reachable, open, and free. And then on the community side, we want really to have a global open solution, not only for antivirus labs, but also for the general public, that cannot afford specialized and expensive tool sets, but is looking for open and free alternatives, and something that's actually well supported. So we will have forums, knowledge base, and Tomislav will tell you more about it. And the main point being, let's try to have multiple authors around one single distribution that we could agree on as a sort of the reference point in our information exchanges. And then obviously the website itself, is hoping to be one place for different comments and information about the formats and components of TitanMist. Right, so with that, I will pass the baton to Tomislav to give you a deeper dive into TitanMist.
Hello everyone. Okay, it works now. Hello everyone, my name is Tomislav Pericin. I'm one of the founders of Reversing Labs Corporation, and I'm here today to tell you all the nuts and bolts of, behind the TitanMist project. So, if you remember from the last year, we were here at the same place and we gave a presentation about the Titan Engine project. And the Titan Engine project is an open source library with about 400 functions that enables you to create your own unpackers. Now, it is the Titan Engine on which this... Okay, sorry. It is the Titan Engine on which this project has been built, and you can basically think about the TitanMist project as the database around the Titan Engine. So that's the basic idea behind the TitanMist. So in the basic introduction, you have the TitanMist it has its own key features, and that's a tool for format identification and tool for specific unpacking. So in a way, we created a database that connects both identification and unpacking in a single layer. So all the information about the formats that are currently supported and that are going to be supported is going to be available freely in the public database public knowledge base that we just talked about, and that's going to be a Wikipedia-like website which is online right now, and you can go to our website and check it out. So the idea behind the project is that the project itself is easily extendable and community supported. And of course, since we added an update feature to the TitanMist project is always up to date, so you're always up to date with your signatures and unpackers directly from our website. So as people contribute the different solutions to different problems, they will be available as soon as possible. So the infrastructure behind the TitanMist project is really simple. So the TitanMist unifies both identification and unpacking in a single layer, and it has an update feature, and at the back end it has a knowledge base that serves as a reference point for further research. So the knowledge base is just back end information for your research, and just have some samples and whatever you need to conduct your research. So the basic layout of the database is as follows on the screen. So in a nutshell, it's an XML database which has the following features. So for example, it doesn't work.
Can you switch him on the regular mic?
Yeah, because this...
Because yeah, it's like, you know.
Yeah.
Yeah.
Okay. Testing?
Yeah. All right.
Okay. So the database looks like this. It's basically an XML file which has all the signatures and all the patterns you need to identify files. So if you look at the sample XML output, it's basically a database of entries. And by entry we mean one or more signatures that connect that entry to a specific format. So you can have signatures, multiple signatures for a single format. So one entry would be, let's say, UPX, and you can have multiple signatures for the UPX file format. And correlated to that, you have unpackers, which you can have multiple types of them, and we're going to talk about that a bit later. And once you have the match, the available unpackers can be called, so the process of unpacking is automatic. You have some other fields that describe the file format. So you have the name of the format, which in the UPX's case would be UPX. You have